Here is worksheet 6.5. We're graphing linear inequalities on the coordinate plane, or with two different variables because we have an x and a y. So here we go. You'll notice the first many of these on this practice is in slope-intercept form, which is awesome. So we start graphing the line. Now I notice that once I graph this line, I'm going to make it a solid line because we have the equal sign underneath the inequality. So my slope is -3/4. What's my y-intercept? What's being added or subtracted to the x? Nothing. So my y-intercept or beginning point is 0. So I start right there at the beginning point or the y-intercept, and then I go down 3 right 4, down 3 right 4. I can also go up 3 left 4 from the y-intercept. And then again, because of the equal sign, check your notes. Whenever we have this symbol, whenever we have the equal sign underneath it, we make it a solid line. Now we have to do a test point, but we can't test the point 0, 0 because it lies on the line. There's a rule that our test point can never be on the line. So let's try, you can try any point not on the line. Just label what it is and where it is. So I'm going to do 0, 2 here. So I'm going to plug 0 in for x and 2 in for y into the original equation. So 2 is greater than or equal to -3/4 times 0. I had a fraction, but I'm multiplying it by 0. 0 times anything is 0. So I simplified that. Now I analyze, is this true or false? Is 2 greater than or equal to 0? It's true. So true, I'm thinking towards. That means from the line, I'm going to shade towards the point. So this whole region here, including that line, is my solution set. All those points make this inequality true. Let's try another one. We have y, this is in slope-intercept form. The y-intercept is -4. The slope is -6/5. So y-intercept's at -4. Now I would go down 6 and right 5. I can do that. I can extend the graph, but it's, instead I'll go up 6 and left 5. That makes a negatively sloped line. It would have been just like going from our y-intercept down 6 and right 5. Negatively sloped line. Now which side of that line do I shade? So let's test the point 0, 0 now. So 0 goes in for y. 0 is less than or equal to -6/5 times 0 minus 4. I get 0 is less than or equal to -4. Is that true? Or you could read -4 is greater than or equal to 0. That's not true. So from the line, I'm going to shade, when it's false, I shade away. True, shade from the line towards the point. False, shade from the line away from the point. This is my answer. This is where I'm going to shade. If this point does not work, neither does everything on its side of the line. Remember, over here we tried this point right here. It was true, so everything, that is a solution, and so is everything on that side of the line with it. Try some of these. Number 4 might get you. Remember, if it's a horizontal line, well, I shouldn't start there. If it's y equals, it's going to be a horizontal line. If it's x equals, it's going to be a vertical line. So I have a horizontal line at 0. Horizontal. Ooh, hello, Mr. P. Is that going to be a solid line or a dashed line? That one's going to be a dashed line. Now this is actually kind of mean to make you put a dashed line on the x-axis. So I don't know, just make these things like really huge with your pencil or pen, so I can see that that's where you're going at. You can also, what a lot of students do is extend the axis. So it's really over here that I can see that it's dashed. There we go. Yeah, all right. So then we can't test the point 0, 0. Maybe we'll test this one right here. So our TP, our test point, is 0, 3. So Whenever I see an x, I plug in 0. Wherever I see a y, I plug in 3. Well, there is no x to plug 0 into, so I put 3 in for y. 3 is less than 0. 3 is less than 0. Is that true? There's no simplifying to do here. That's nice. Now I just need to analyze it. Is that true or false? That is false. So from the line, I'm going to shade away from the point. This point is not true, nor is anything on its side of the line. Anything down here would be true if you plug in any of these y values or any of these coordinate pairs. Now, I didn't mention the x's because there are no x's in this equation. If you plug in any of the y's down here, it's the y values, the heights, are less than 0. So over here, we're getting the standard form. So on standard form, this is where it's whatever method you want to do that's easiest for you. Although I will have to say that some of these might not work out very cleanly. I think I modified this. I'm actually going to stop here and I'll make a separate video for it.